Okay, so number 7 is very similar to number 6. The only difference is we are now given our angles in radian form. Okay, so unit circle memorization is going to help tremendously with this again. So let's find 5 pi over 2. We need to identify that first this is pi over 2. Okay, so if I go 90 degrees 5 times, so there's 1, 2, 3, 4, and then back here, I'm going to terminate right here. That's where the side will terminate for this angle. And the point there is 0, 1. And we know that sine is just looking for the y value, so the answer is just going to be 1. Okay? Let's do the next one. We have 3 pi over 4, meaning our reference angle is pi over 4. And by unit circle memorization, I know that 1 pi over 4 is here, and I want to travel 3 of those. So it'll be 45, 90, 135, otherwise known as pi over 4, 2 pi over 4, and 3 pi over 4. So this right here will be at 3 pi over 4, which the point is root 2 over 2, root 2 over 2, with a negative x, positive y value. The tangent is y over x, otherwise known as y over x. And yes, you can write it as y over your x value of negative root 2 over 2, or you could just write it linearly, if you will. So it'll be root 2 over 2 divided by this negative root 2 over 2. And 5th grade tells us we could do keep, change, flip. Okay? We know these 2's are going to cancel to 1. These are going to cancel to 1. And now I'm left with a negative, which would give me a negative 1. So the slope at 3 pi over 4 is a negative 1. So I just said slope because slope is the same as tangent for those of you who want a shortcut. At these 45, 45s, if it ends up being here at 45 degrees or here at 225 degrees, it's going to be a positive 1. If it ends up being here or here, otherwise 3 pi over 4 or 7 pi over 4, it's going to be a negative 1. Because you can see that this line right here, if I were to draw a line between those two, would have a negative 1 slope, and the other one would have a positive 1 slope. That only works for tangent. So if you want a shortcut, that only works for tangent. Let's look at our last one. We have 7 pi over 6, which means our reference angle is pi over 6. Okay? So at pi over 6, which we know is here, so there's 45, 60, and here is this 30 degrees, otherwise pi over 6. We want to do 7 of these. Okay? So the question you'll ask yourself is, how many of these pi over 6's would it take to get here? And by now we should know 6, because 6 pi over 6 would reduce those 6's to a form of 1, otherwise giving us the angle of pi. Okay, so we have 1, 2, 3, 4, 5, 6. Okay, we skipped that 45 right there. And if I were to go one more, since I'm traveling 7 pi over 6, it would be in quadrant 3, which if I were to put the 3 angles, this is going to be this reference triangle of 30 degrees, otherwise pi over 6. So we're going to say here is where I would end up with my point. Now doing a point, as far as a coordinate point there, it'd be root 3 over 2, 1/2, and it would be a negative x, negative y, and we're looking for the secant. So the secant is associated with cosine. Cosine is the x value. So all I could do is find the x value and then take the reciprocal, because we're looking at the secant. Again, the secant is the flip, otherwise the reciprocal of cosine. So you could write the reciprocal of that fraction would be a negative 2 over root 3. And yep, we are going to rationalize that denominator by multiplying by a form of 1, so that the denominator becomes 3 from that. and then a negative 2 root 3 up top. So negative 2 root 3 over 3 would be my answer, and you just have to check. Do the negative 2 and 3's reduce any? And if they do not, that is your answer. So we get 1, negative 1, and negative 2 root 3 over 3.